Hi GOR, this is Unit 4, Lesson 5, and today we're going to talk about similarity criteria for triangles. So I'm going to start with this big triangle right here, triangle ABC, and then triangle A prime, B prime, C prime, which I'll call triangle 2, and then triangle A double prime, B double prime, C double prime, which I'll call triangle 3. So they want us to find out the similarity transformation that maps one triangle to the other. Like, how did I get from triangle 1 to triangle 2? Did I reflect it, rotate it, dilate it, translate it? What did I do? Well, you can see that the size has changed, so that means I must have done a dilation. And then how did I get from triangle 2 to triangle 3? Well, the size stays the same from 2 to 3, but I have flipped it, so that means I must have done a reflection. So that's just a review of some things that we've talked about already. What we're really going to talk about today is the different ways I can prove triangles are similar to each other. So the first way and the most popular way, especially for doing proofs, and yes, I know I said the word proof, so we are going to do a proof here, but these proofs are much, much easier because in order to prove triangles are similar, I just need two angles, so angle, angle. So basically, if I have angle A congruent to angle D, and angle B congruent to angle E, then my triangles are similar to each other. Now, angle C and angle F are also going to be congruent, but I don't have to prove that. Once you have the two angles congruent, that is enough to say that my triangles are congruent to each other, because the third angles automatically will be congruent. This is the method that I use when I'm doing proofs, angle, angle. Okay, but there are two other methods as well, but I won't use them for the proofs. The other way is side, side, side. Now this is different than the side, side, side when we talked about congruent figures, because the sides are not congruent here. The sides are in proportion to one another. All right, so if I know that AB over DE, those are the sides I have marked with the red arrow, and if that equals BC over EF, those are the sides I have marked with the purple arrow. And if they are in proportion to AC and DF, which are the sides with the blue arrow, then my triangles are similar to each other. So again, the sides are not congruent, they're just in proportion. And the third way is side, angle, side. Side, angle, side means the two sides are in proportion, and the angle between those two sides are congruent to each other. And that's the third way to prove that triangles are similar to each other. Now, just like congruent triangles, once the triangles are similar to each other, then that means the remaining angles are congruent and the remaining sides are in proportion to one another. So this right here is sort of like the CPCTC. Once the triangles are similar, then the sides will be in proportion. All right, so what kinds of things do we have to know? Well, we have to be able to do a basic proof. And here's what a basic proof would look like. I want to prove that triangles are similar. And I know a lot of you didn't like proofs, but look how easy this is going to be. So basically, AB is parallel to CD. If AB and CD are parallel, okay, and I have that marked with that little greater than sign right there, then that makes, and that's my given, that makes angle A congruent to angle D, and angle B is congruent to angle C, because those are alternate interior angles. So A is congruent to D, and C is congruent to B. Now, once I have two angles, the triangles are similar. I'm done. All you need for similar triangle is angle, angle, and I have angle, angle. I also have the vertical angles in there, so you could have put that as well, but my triangles are similar. So you're going to find these proofs much, much, much easier. All you need are two angles. What similarity transformation maps ABE onto DCE? Well, I changed the size, so that means I must have done a dilation, but I also rotated it. I rotated it 180 degrees about point E. All right. We've said this before. If two triangles are similar, what's true about their corresponding angles? Their corresponding angles are congruent. What's true about their corresponding sides? The sides are in proportion. Let's do an algebra type problem. So we did a proof, which was pretty easy. It was just angle, angle. And now we're going to do an algebra problem here. So I'm telling you that these two triangles are similar to each other. See how it says that they're similar? If they're similar, then their corresponding angles are congruent and their corresponding sides are in proportion. Well, let's see what they gave me. They gave me that angle C, which is right here, is 4x plus 30. And they told me that angle G, which is right here, is 5x plus 10. Now those are corresponding angles. I can see it on the picture, but I can also see it right here. C is the last letter and G is the last letter. So those are congruent to each other. Angle C is congruent to angle G. If the triangles are similar, the corresponding angles are congruent. So all I'm going to do is take angle C and set it equal to angle G and solve. And that's it. So I'm going to subtract 4x from both sides. And then I'm going to solve for x, so I will subtract 10. So x equals 20. And that's all they wanted me to find. All right, so at that point, I am done. And I think that's it for it. Yep, that's it for today. And we will practice some more tomorrow with saying why triangles are similar to each other and then writing some equations like